Well, hello everybody. Let me show you what you missed from the other day. What we did is we gave back tests over our Chapter 6. So if you haven't seen yours and would like to see it, still see us, and we'll show that to you. And then we started our last chapter of the school year over what's called sequences and series. So hopefully you have your class notes right there in front of you. And I'm just going to kind of jump right in this. It's not a hard day except for one place where there's some terminology that confused the class. So if you can stay with me during that part of the lesson, it's not going to be a bad day for you. But look at your number 1. 1, 2, 3, and 4 to be truthful. What I did is I just kind of wrote up some patterns. A sequence is just some pattern. You can make up your own. You can figure out the pattern to it. Like if you look at your number 1, notice it goes 54, 57, 60, 63. Well, you probably figured that pattern out. We're adding 3 each time. So this is going to be a 66, that's going to be a 69, and that's going to be a 72. That's called an arithmetic sequence. You don't have to know that today, but we'll start building on it next time. If you look at number 2, you could pause there a little bit and see if you can figure it out. But it looks like from here to here, we added 2, and then 3, and then 4. Well, the pattern could be, I'm going to add 5 and get 15. I'm going to add 6 and get 21. I'm going to add 7 and get 28. So there's my pattern. That one doesn't have a special name. It's just some pattern. Number 3, I'm going to go 1, and then 2, and then 4, 8. Well, you probably figured this one out. That's going to be 16, 32, and 64. That one we're just doubling. That's called geometric. Like I said, today you really don't get caught up in that. In a few class periods we will. And on number 4, if you peek at that one for just a second, you'll probably figure out we're dividing by 2 each time, or dividing by 2 is the same thing as multiplying by 1/2. So either or, but half of 16 would be 8, then 4, and then 2. So those are just patterns. We're going to talk about certain kinds of patterns and way to represent them here in a second. Some notation that you're going to see today. The variables does not matter. So here's what I mean. This pattern right here is adding 4 every time. So I know it's called an arithmetic sequence. You don't have to know that right now. But I just said arithmetic, so I'm going to use the letter A. Here's some notation that you would see. You would see a A with a little bitty 1 down there. And that's pronounced A sub 1. All that means is the first term in this sequence has a value of 3. That's all that means. A sub 1 is the value of the first term. A sub 2 would mean what's the value of the second term. So in this case, 7. If I went to A sub 5, 1, 2, 3, 4, 5, that would be 19. So it's just notation. A sub 4 would be the 4th value. So 1, 2, 3, 4, that guy right there. Some other notation that you're going to see, you're going to see A sub n, which means I don't know which term I want to talk about, so it's just my vague term. Here in a little bit, you're going to also see A sub n minus 1. And all that means, guys, is the previous term. That's the confusing part of the day right there. So look at your number 5. It says, list the first 4 terms for each of the following explicit formulas. You will need to know what an explicit formula is today. In an explicit formula, it looks like these. In an explicit formula, you're just given a formula. You're just given a formula. To figure out the first 4 terms, here's all you're going to do. I'm going to plug in 1, and then a 2, and then a 3, and then a 4. That's all you got to do. So here's what it's going to look like. A sub 1 means plug 1 in wherever you see an n. So I'm going to have 3 times 1 plus 4. So the value of my first term is 7. 3 times 1 is 3, plus 4 more is 7. So my first term is 7. Now I want my second term, a sub 2. I'm going to plug in a 2 right there where the n is. So I'm going to go 3 times 2 plus 4, and I'm going to get 10. That's all there is to it. I'm going to find a sub 3. So I'm going to plug in a 3. 3 times 3 plus 4 is going to be 13. And they wanted the first 4, so to get my fourth term, plug in a 4 and get 16. So there's my first 4 terms generated by that formula. So you're just plugging in 1, 2, 3, and 4. If we wanted the first 100, you would plug in 1, 2, 3, 4, 5, all the way to 100. But we wouldn't do that to you. So here's number 6. I'm going to plug in a 1, and then a 2, and then a 3, and then a 4. So the value of my first term, notice what I did there, guys? It doesn't matter. I used an A over here. I'm using a V here. The letters don't matter. So V sub 1 is going to be 1 squared plus 3, which is going to be 4. The value of my second term is going to be 2 squared plus 3. 2 squared is 4, plus 3 is 7. The value of my third term is going to be 3 squared plus 3, which is going to be 12. And the value of my fourth term is going to be 4 squared plus 3, which is 19. Now when I list it, 4, 7, 12, 19. There's the first 4 terms. You don't have to do all of this extra work unless you're told to. On this one it says use correct notation on number 5 and number 6. So I needed to do that. Now on the rest of them, guys, we're just going to plug the numbers in. So on number 7, I'm going to put down a 1, 2, 3, 4. And then you're just going to grab your calculator and go 1 squared plus 2 times 1 minus 3. You're going to type in 1 squared plus 2 times 1 minus 3 equal. And when you do that, I got 0. And then you're going to do the same thing for a 2. You're going to type into your calculator 2 squared plus 2 times 2 minus 3. And when I did that, I got a 5. And then you're going to plug in 3 and 4. So it's going to look like 3 squared plus 2 times 3 minus 3. And when I did that, I got 12. And when I plug in 4, 4 squared plus 2 times 4 minus 3, I got 21. That is all there is to it. To list the terms, just plug in the numbers. I will show you how to do this on your calculator another way in the future. Look at your number 8, though. It gets a little trickier. Notice that there's an N right here and an N right there. So I'm still going to plug in 1, 2, 3, and 4. Why 1, 2, 3, 4? It says first 4 terms. So now here's what you're going to type in your calculator. You'll type in parenthesis -1, close your parentheses to the first, times 3 to the first. And when you do that, you get -3 for your first term. To get your second term, you're going to go parenthesis -1 squared times 3 squared, sorry about that, and get +9. To get your third term, -1 in parentheses to the third times 3 to the third. When you run that through, you get -27. So here's what I got so far. I got -3, +9, -27, and when you use a 4, you're going to get +81. Hey, I want you to notice something on this. Notice how it went negative, positive, negative, positive. Whenever you have -1 to a power, your signs are going to flip-flop. Your signs are going to flip-flop. Here's my number 9. Remember, guys, we're just plugging in 1, 2, 3, 4. It's going to look like this, though. I'm going to have parenthesis -1. Do the exponent part in your head. 1 minus 1 is 0. So I've got negative 1 to the 0 times 2 to the first. I've got negative 1 to the 0 times 2 to the first. And when you do that, you're going to get positive 2. Now let's pick on a 2. Negative 1 to the 2 minus 1 is 1 times 2 squared. When I did that, I got negative 4. And then I'll do the same thing for 3 and 4. So my sequence looks like 2 comma, negative 4 comma, and then if I plug in 3, I'm going to get 14 and negative 22. So that's all there is to it. I'll do one more before I move on. 1/2 n plus 3/2. I'm going to plug in 1, 2, 3, 4. This one's a lot easier than the ones we've been doing. You're going to go 1/2 times 1 plus 3/2, and you're going to get a 2. Then you're going to plug in a 2, and you're going to get 2.5. Then you're going to plug in a 3, and you're going to get 3. Then you're going to plug in a 4 and get 3.5. That's all there is to it so far. So if you're asked to generate the sequence, you're just plugging in some numbers. Now number 11 is going to be tough for a second, so hang with me for a second. This is where we lost the class. As soon as they realized what it was, they thought it was really easy. Just realizing it is tough. This is what's called a recursive formula. In a recursive formula, they tell you the first term. That's what this part is. A sub 1 is 3. V sub 1 is 7. A sub 1 is 5. V sub 1 is 5. They tell you the first term. And then what they do is they give you a formula how to get the rest of it. So hang with me on number 11 here. I'm going to show you all the steps on it, but I'm going to keep repeating something. So number 11, it says A sub 1 is 3, so I'm going to plug a 3 right there. Now check this out. I'm now looking for term number 2. So look at this formula right here and concentrate only on this part for me. It's going to look like this. A sub 2 is going to be, I'm going to plug a 2 right here for a second. 2 minus 1 is 1. So it says A sub 2 is A sub 1 plus 5. But A sub 1 we know is 3. So 3 plus 5 is 8. Now let me read this to you. It said A sub 2, the second term, is the first term plus 5 more. So all I did is I took this term, and in this case I added 5 to it. Look what happens for the third term. A sub 3 is going to be 3 minus 1 is 2. A sub 2 plus 5. What does this say in English? The third term is the second term plus 5 more. The second term plus 5 more. Bam. If I'm picking on the fourth term, it says A sub 4 is A sub 3 plus 5. It says the fourth term is the third term plus 5. So this becomes 20. Plus 5 plus 5, yep, plus 20. Oh wait, how about, let me backtrack real fast. 8 plus 5 is going to be 13, and that's going to be 18. Sorry about that. Okay, hey, so let me beat this up for you just a little bit more. This really says my next term is my previous term plus 5 more. That's all that says. Look at your number 12 while I got you a little bit confused. It says the value of my first term is 7. So I'm just going to write down a 7. Here's all this part says. I'll take care of this part here in just a second. It's just notation. Do not get caught up in it. This says my second term is 2 times the previous term minus 4. So I've got 2 times 7 minus 4. That's going to be my next number. Well, 2 times 7 is 14. 14 minus 4 is 10. Now let's go get our next term. It says it's going to be 2 times 10 minus 4, which is going to be 16. See, so don't get caught up in the notation for this. All that means right there is previous term. My next one, guys, 2 times 16 minus 4, which is going to be 32 minus 4, is going to be 28. There it is. So it's just notation to say previous term. That's all there is to it. Look at your number 13. Oh, let me backtrack just a little bit. Hey, the purpose of this n greater than 2, it has to be there. And here's all it's saying. Once again, it's notation. It's saying this formula right here is only good for the second term on. The second term, the third term, the fourth term. I can't put a 1 there because I already don't know what my first term is. So you'll see this on every one of them. And when we write our own, you'll also see it. But it doesn't, it means a lot, but don't get caught up in it. Here's number 13. It says a sub 1 is 5. So I'm going to write down a 5. Think about your next term then. Here's what it says it's going to be. It's going to be 6 minus 2 times the term that you see, 10. So 6 minus 10 is negative 4. Now let's go get our next one. It's going to be 6 minus 2 times negative 4, which is going to be 6 plus 8, which is 14. My next one, 6 minus 2 times 14. You can type that in your calculator or your brain, but it's going to be negative 22. So hopefully you're catching on how easy this is. What do you think about number 14? Your first term is going to be 5. Your next term is the previous term squared. So 5 squared is going to be 25. Then I'm going to go 25 squared is 625. And then I'm going to go 625 squared and get 390,000. Let me erase some room here. 390,625. Hey, notice I did not put a comma in here because I didn't want to confuse you with the term. Here's my number 15. I used a G because I knew it was geometric. You didn't need to know that yet. All you need to know is this. My first term is 120. My next term is a half of the previous term. So a half of 120 is 60. A half of 60 is 30. A half of 30 is 15. And then we got it. Oh, let's go one more. Half of 15, 7.5. My number 16. Your first term is 11. Well, now I need to take 11 times negative 1/3. You can do that in your calculator. I'm just going to multiply straight across, though. 11 times negative 1 is negative 11 over 1 times 3 is 3. Now I'm going to take negative 11/3 times negative 1/3. Negative 11 times negative 1 is positive 11 over 3 times 3 is 9. Like I said, you could be using your calculator. If I multiply by negative 1/3 again, I'm going to get negative 11 over 27. And if I go one more time, I'm going to get positive 11 over 81. I will show you how to make sure you can do that on the TI-84 calculator also. But that's how we handle a recursive formula. Going to change the game just a little bit. On numbers 17 through 22, you're going to write your own recursive formula. That's the ones that we just worked with. Remember, in a recursive formula, you tell the world what your first term is, and then you tell them how to get to the next one. So first off, look at number 17 for me, and tell me what it's doing to go from term to term. And I'm hoping that you said, I'm just adding 4. Well, here's what it's going to look like then. I need these cool parentheses to show that what I write goes together. And I'm going to pick some letter. I'm going to use A's or B's. I'm going to say A sub 1 is 5. And now, here comes the notation. I'm going to say A sub n, my next term, is my previous term, A sub n minus 1, plus 4 more. And then, I got to tell people for n greater than or equal to 2. All that means, guys, is this formula only works for your second term up, your second, your third, your fourth. It will be here every time. It'll be there every time. Peek at number 18 for me. Try to decide what it's going up or down by. See if you can figure out the pattern. And in this case, I hope you're saying that it's minus and 5 every time. If you can, the hard work's done. Cool parentheses, that brace. A sub 1 is 100. A sub n is A sub n minus 1, the term in front of it, minus 5. Then I'm just going to put comma for n greater than or equal to 2. That'll be there every time for you. Peek at number 19, see what you think. Even if you're lost on these, we now know this much. I can say A sub 1 is 25, and I can say A sub n equal. At least I know that much. But see if you can figure out what we're doing. Looks like it's going down by 2.5 every time. So it's going to be the previous term minus 2.5, comma, for n greater than or equal to 2. Number 20 is a little harder. Usually, somebody in class figures it out. So let's look at number 20. I've got A sub 1 is 3. A sub n is. See if you can figure out this pattern. And then usually somebody figures out that it looks like I'm doubling this term and then taking 1 away. 3 doubled is 6, but 6 minus 1 is 5. 5 doubled is 10, but 10 minus 1 is 9. Here's how I would write that. It's twice the previous term. Oops, I'm going to use an A. It's twice the previous term minus 1. Then I got to put my little notation on there. For n greater than or equal to 2. And I got 2 more before I change gears a little bit. Just kind of tie some things together. Look at number 21. See what you think that's going to do. 500, 250, 125, half of 125. So it looks like I'm multiplying everything by a half, or dividing by 2. So when I write this, I'm going to switch letters on you. It doesn't matter if you do or not. I'm going to say G sub 1 is 500. You'll know this soon. I used a G because I'm using multiplication or division. It means geometric. So G sub 1 is 500. G sub n is a half of the previous term. And you knew what I was going to almost forget. For n greater than or equal to 2. So there you got it. And number 22 is kind of a little tricky one. See if we can figure out what's changing there. Plus 300, plus 450, plus, oh boy, that's a mess. I do know this much though. G sub 1 is 600. G sub n equal. And notice, somebody in class usually gets this. Notice that the next term is the previous term plus half of it. Like 600 and half of 600, which is 300, would give me 900. Half of 900 is 450, plus 900 is 1350. So it's the previous term times 1.5 for n greater than or equal to 2. A cleaner way to write that one would be 3/2 of the previous term. But it doesn't matter. But that's how you do a recursive formula. You need the parenthesis. You need to tell the world what the first term is and how to get from term to term. It's just notation. You're at that level where the notation's a little tougher. And it looks like I got about 5 more minutes to this video is all. So look at your number 23 if you would. It says, last but not least, you're given an explicit equation. That's what we started the class off with. List the first 4 terms, and then write a recursive formula to represent that sequence. So starting off, we're given an explicit. So you're just given some equation. Remember how to get your first 4 terms? Plug in 1, 2, 3, 4. So I'm going to go 2 times 1 is 2, plus 1 more is 3. Then I'm going to plug in a 2. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 more is 7. 2 times 4 is 8, plus 1 more is 9. There I listed the first 4 terms. That's what we started class off with. We've already done this. Now let's list it as a recursive formula. So there's my cool parenthesis. I'm going to say a sub 1 is 3. And notice I'm going up by 2 every time. Notice the slope was 2. So my next term is my previous term plus 2. And I need that notation for n greater than or equal to 2. Here's my number 24. We're going to plug in 1, 2, 3, 4. When I plug in a 1, 5 times 1 is 5, minus 3 is 2. When I plug in a 2, 2 times 5 is 10, 10 minus 3 is 7. And then I get a 12 and a 17. So notice what they're doing? They're adding by 5 each time. So here's my recursive formula. A sub 1 is going to be 2. A sub n is going to be the previous term plus 5 more for n greater than or equal to 2. And we would do number 25 the exact same way. I would simplify this one first, though. I'd call this 2n minus 2 plus 7, 2n plus 5, and then do what we did up there. So last but not least, an explicit formula will always look like this. You'll have a sub n, g sub n, v sub n. You'll have something is some formula. You'll have that every time. In a recursive formula, though, you'll have this. You'll have the brace, the cool parenthesis, and you'll have a sub 1 is some number. You got to tell people where to start. And then you'll have a sub n equal, and there's going to be a sub n minus 1 there. You'll just have to tell the people what to do. Are we adding something, multiplying something? So I could have some other stuff. And then remember, it always looks like that. So that's the lesson that you missed the other day. Not a hard lesson, just some notation. So good luck on your assignment.